And here we are with a familiar guest on this Sunday evening update. It's Nason Schooler, who the Immortality Institute did raise some money for some lifespan experiments with worms. And we're going to be starting that up once again here in Iowa. He's got a nice little lab set up here. And why don't you, for some people who might not have been around for the original, the first trial run of the experiment, can you give us a little background on it, just a real general overview?
Yeah, so basically the idea is that one component of the aging process is aging pigments that accumulate and within the cells. And there's a lot of theory that these are harmful to the cell, and as they accumulate within the cell over time, that they start to kill an organism, basically.
And they could be one of the key drivers,
one of the components that contributes to the deterioration with aging. So as a possible treatment, and also to test that theory, we basically have latched onto a method for destroying pigments within living tissue that's already used in dermatology and ophthalmology, where they use pulsed lasers to zap pigment granules and destroy them in living tissue, causing a minimal amount of harm to the tissue itself. And so now we're using C. elegans worms, which are a microscopic worm.
The round worms.
Yeah.
Short lifespan.
1 millimeter long, and yeah, they live a couple weeks, 2 to 3 weeks, and that way we can treat them very easily, test the effects on lifespan,
and see if we get the positive or negative effects on the lifespan from destroying the lipophysin. Well, that's great. And now let's take a look at some of the equipment that Nason will be using down here in the lab. And what we have here is where Nason is going to be culturing the worms. We've got a little refrigerator here, standard lab refrigerator, I take it here?
No, it's near room temperature. That's the tricky part. You need one that can maintain refrigeration at close to room temperatures. You get your household fridge, it probably won't be able to maintain a consistent 60 degrees because it's too close to room temperature. So, yeah.
And at 60 degrees, that's the way the worms grow the best?
That's the 20 degrees Celsius.
20 degrees.
There's basically 3 temperatures you can do worms at, and 20 degrees is the middle of the road. Is the standard for most lifespan experiments.
Okay.
You can do a little warmer. You can do 25 degrees Celsius, and that'll do much shorter experiments. And
they grow faster. They live shorter lives.
Yeah, it's crazy. You have trouble within 24 hours. You have trouble grabbing your worms before they were fruitful and multiplied, and now you have a whole plate full of worms, and it gets really crazy.
Oh, okay.
But and then you can do a 16 degrees C, and that's kind of the standard for longer term storage of the worms and kind of maintaining them in the background.
And the typical lifespan is 3 weeks or so of
yeah. At this temperature for the wild type, you'll get some of them that'll get close to 2 to 3 weeks. Most of them will kill over about 14, 15 days. But there's always a few stragglers that'll.
And now we're taking a look at the laser that'll be used in the experiment. Can you explain the laser here? How it operates and how you're going to laser the worms?
So this is the laser itself, really, all in this handpiece.
Okay. And this is like the power source here.
Yep.
Okay.
This is the power supply. It also contains a water pump, and you see this with. It's a typical setup for lasers. Basically.
Okay.
There's usually a head unit and then like a remote unit that has the
I see.
Guts basically. But the tricky part is all of the sensitive optics that are precisely aligned to get the beam just perfect are in here. So you don't want to drop the thing. Then you have to send it back to San Francisco and repair it for a couple $100 and use another one. But
and then when you're going to laser the worms, you're going to have a structure such as a vise or a
I'll set up a bracket.
Bracket
with something height adjustable, because I have to be able to lock it in it. Well, the laser has 2 different wavelengths. It's actually coming out of the beam, coming straight out of the device. It's like an infrared. It's 1024 nanometers, and it's got a small optics device I left in the case there that will basically double that back on itself, so you get double the wavelength or double the frequency, and that'll give it like a 532 green color, and we'll be using both of those to treat the worms. The green is pretty harsh because it's very effective at removing pigments, but I think that's going to be useful because the worms.
And here we have a microscope, so you can take a look at some of the worms as they're growing, after they've gone through their treatments.
Well, and that's how I transfer the worms from point A to point B, from plate to plate.
Oh, okay.
We use this scope all the time. It's like a essential component of worm maintenance, basically.
Okay.
But yeah, for now, to look at what we've done, that's what we're using. I'm planning on getting a better scope so we can actually image the effects of what we've done and catalog those things.
All right.